Hello everyone. Welcome back to this lecture series on engineering mechanics. This is lecture 12 and we are going to discuss on non-concurrent forces in space, a special topic under the wrench applications. In the previous lecture, we discussed non-concurrent forces in space with a special emphasis on couples and their rotational effects. We learned that a couple produces pure rotation without any translation and its moment is independent of the point of reference. In today's lecture, we extend the concept further and introduce an important application known as a wrench. The idea of a wrench directly connects force coupled systems with real engineering tools and mechanisms. In everyday language, a wrench or a spanner is a tool used to tighten or loosen nuts and bolts by applying the torque. However, in engineering mechanics, the word wrench has a very specific meaning. A wrench is a force coupled system in which the force and couple are parallel to each other. So this definition is extremely important. Unlike general force coupled system, in a wrench, the line of action of the force and the axis of the couple are aligned in the same direction. Here the wrench systems commonly appear in tightening or loosening the bolts, the pipe joints, shafts which are subjected to torque, and machine components experiencing combined force and rotation. A wrench represents a situation where a couple tends to rotate the body and the force tends to translate the body where both effects act along the same axis. This makes the wrench a combined translation as well as rotational loading system. Here the wrench produces both the translation and rotation along the same direction. This is why it is so commonly encountered in mechanical and structural system. Now let us look at the first numerical example in which a force is applied to the handle of a socket of magnitude 110 Newton. And we are asked to replace this force by an equivalent force coupled system at a reference point, that is the O point, that is what is the reference point which has been asked, usually the origin. So this problem represents applying force at a distance from a bolt axis which produces a torque that rotates the fastener. In practice, the force causes translation whereas the offset produces a moment. Together, they form a wrench system. Now the question is, why we replace the force by a force coupled system? In engineering analysis, forces are often transferred to convenient reference points, whereas the moment accounts for the rotational effect lost during transfer. And this simplifies the free body diagrams, equilibrium analysis, as well as design calculations. So the couple moment obtained in a wrench which has a specific direction that indicates the axis of rotation. And this direction is determined using the vector cross product as well as the right hand rule. So in design, the direction tells us whether the applied torque tightens, loosens, or causes any unwanted rotation. Now we'll solve this problem in a step-by-step manner. Now you can see the 110 Newton force which is applied at the end of the socket is acting in a vertical plane parallel to YZ plane and is applied to a 220 mm long horizontal handle AB. So the length of the handle AB is given as 220 mm. And the force is applied at the end of the handle AB and which is having an inclination of 15 degree with respect to your Z axis. And remember, the force is parallel to the YZ plane, which means it will not have any X component. So now resolving this force, angle is given 15 degree with respect to the Z axis. So that 110 cos 15 will give the Z component of the force. Similarly, rotating towards the nearest to y axis, it will be going in this direction. whereas the z component will be going in this direction. This is what is your Fz and this is what is your Fy. And Fz is acting along the positive direction. So this will give 110 cos 15 degree. Whereas Fy is acting in the downward direction. So that will give minus 110. This is cos in the sense, this will be sine 15 degree. That's what has been written here. So 110 into minus sine 15 j vector, since it is acting in the y direction and to downward direction, and cos 15 k vector, since it is acting towards the positive z axis. So solving this one, you'll get the force vector minus 28.47 j vector plus 106.25 k vector. Now the question is not only to find out the force in terms of vector, we need to replace this force into a equivalent force couple system at the origin O. So in that case, let me assume the origin O with the coordinate 0, 0, 0. And your force is acting at the end of the handle B, which means that I need to find the coordinate of the point B with respect to O, or O is the origin. And then if you know the coordinate, I can able to find out the moment of this force which is applied at the end of the handle B about the point O. That's what is the question which has been asked. So in that case, first let me calculate the coordinates of the point B. So here, the length of the handle is 220 mm or otherwise 0.22 meter, which is inclined at an angle of 35 degree with respect to your x-axis. So the x component of the point B will be 0.22 into cos 25. If I am rotating about this point in the sense, it will be acting parallel to the x-axis until it is acting in the positive direction. So that coordinate will be 0.22 cos 35 degree. Now regarding the y component, wherever it is acting, it is lying in the same vertical line, that is 150 mm. So in that case, y component will be 0.15 in terms of meter. Whereas the z, if I am rotating means about the x-axis, it will be going in this way. If I am rotating about the z-axis in the sense, it will be going in this way. So if this is 35 degree in the sense, this will be 65 degree or otherwise 90 minus 35 degree. Sorry, 55 degree. Right. So if I am resolving about the x-axis, you will get B will be 0.22 into cos 35. With respect to z-axis, it will be 0.22 into sine 55 degree. That is what, or sine 35 degree, sorry, sine 35 degree. So that is what has been given here. So 0.22 cos 35 will be the positive side of the x-axis. 0.15 is the y which is lying above the origin, so positive. And whereas z, it is lying behind the positive side of the z-axis. That's why minus 0.22 sine 35. So solving this one, the coordinates of the point B will be known 0.18, 0.15, minus 0.13. And now we know that moment vector will be equal to r vector cross f vector. Already the f vector has been calculated. So we are supposed to find out the r vector. So here r vector in the sense the displacement vector. How to find out this one is where the force is acting minus where the moment has to be calculated. That is nothing like here. In this case, it will be B to O. So the displacement vector r B to O will be 0.18 minus 0 I vector, 0.15 minus 0 j vector, minus 0.13 minus 0 k vector. So now r vector is known as well as f vector is also been calculated. Now we can put that m vector. M vector will be equal to ijk 0.18, 0.15 minus 0.13. That is what is the displacement vector. Regarding the force vector, there is no I component, that will be 0. So minus 28.47 and 106.25 with respect to y and z axis. So solving this determinant, you will be getting the moment vector. And getting the modulus, you will be getting the magnitude of the moment vector. That is what has been asked. We are supposed to replace the force with an equivalent force coupled system about the origin O of the coordinate system. This is what has been asked. So which is a moment about the point O, it's not A. Moment about the point O will be 23.28 Newton meter with the resultant of minus 28.47 J plus 106.25 K. Now let us consider the second application in which the pipe wrench problem has been taken into account. Here, in order to unscrew the tapped facet at a plumber uses two pipe wrenches as shown. One in this direction, one in this direction, applied with the same amount of force. By exerting a 40 Newton force on each wrench at a distance of 10 centimeter from the axis of the pipe and in a direction perpendicular to the pipe and to the wrench, he prevents the pipe from rotating. Understand, right? So if you are applying the force, this tap facet has to be unscrewed. In that case, here one wrench has been placed in which the force will be applied in the anti-clockwise direction. If you are applying the anti-clockwise direction, this pipe tends to rotate along with the facet. In order to avoid that pipe also should rotate along with the facet, one more wrench has been placed at a distance of 7.5 centimeter from the tapped facet, and that will be in which the same amount of force 40 Newton which is applied opposite to the direction which is applied at a point A to avoid the rotation of the portion AC. That is what has been given here. He prevents the pipe from rotating and thus avoids loosening or further tightening the joint between the pipe and the taped elbow C. Determine the angle theta. This is what we need to find out. The angle theta that the wrench at A should form with the vertical and the force couple system at C. The force couple system at C equivalent to the 240 Newton forces when this condition is satisfied, which is nothing like, even though if you are rotating, this taped facet at C should not rotate about the y-axis. That is, it should not be rotating in this direction or in this direction. For which, what will be the force couple system which will be developed at a point C. That is what is the question. Here, two equal forces are applied using two pipe wrenches. That is 40 Newton. The intention is to prevent rotation of a joint, and this is a very realistic engineering situation. Here a plumber applies equal forces at specific angles to ensure that one joint rotates and another joint remains stationary. Here the joint A should rotate whereas the joint C should be stationary. Here, why is this a wrench application? First is this question. Each applied force at A as well as B produces a moment about the pipe axis, that is AC. The combined effects will create a force couple system. By adjusting the angle of application, certain components of moment can be eliminated. An unwanted rotation can be prevented. And therefore, the control of rotation is achieved by controlling the direction and magnitude of the moments, not merely the forces. And this principle is widely used in assembly operations, machine maintenance, or structural connections. Here, the wrench analysis helps engineers to design tools and fasteners, prevent the joint failure, avoid unintended loosening to ensure safety and reliability. In structural and mechanical systems, important torque application can lead to fatigue failure, leakage, or structural instability. Now let us solve this problem in a step-by-step manner. First, let me calculate the resultant force. The resultant force of these two applied value, that is 40 Newton and 40 in the opposite direction. Right. Let me start with this one. The 40 Newton force is perpendicular to this one. Here you can see this wrench is placed at an angle of theta with respect to vertical. If so, this angle will be 90 minus theta. If I am taking a horizontal, this angle will be total is 90, therefore this will be theta. So with respect to x-axis, it will form 40 into cos theta. With respect to y-axis, it will be forming 40 into sin theta. That will be acting in the downward direction. Now moving on with the second one, the second wrench, which is placed at the point B, in which the force is applied parallel to x-axis with a magnitude of 40 Newton. So in that case, the force will have only the x component, that is for 40 I vector. That's it. Now writing that one, We'll start with this one, 40 into I vector. That's what I told with respect to this force. Now moving on with this one, horizontal component will be acting towards left side, vertical component will be acting towards downward direction. Both will create a negative force component. So horizontal will be 40 into cos theta, 40 cos theta, and vertical will be 40 sin theta. That's why 40 cos theta I vector minus 40 sin theta j vector. Now let us calculate the moment about the point C, because they mentioned that it should not rotate about the vertical axis with respect to point C. So for which, first let me calculate the moment about the point C and then equate that the y component of that moment about the point C to 0. Then we can find out the required unknowns. Now let me calculate the moment about the point C. Let me start with this wrench, the wrench at A. So we are calculating the moment about the point C. So the perpendicular distance between point A and point C is 7 plus 7.5 plus 7.5 will give 15. That is what is the displacement vector. So for A, that is RA will be 15. It is acting along the Z direction. Therefore, it will be K vector. Right. Force is acting at A and we are going to take the moment with respect to C. That is why 15 K vector positive. Similarly, for B, if I am calculating the moment of the force which is applied at the point B, RB will be the displacement vector with respect to point B, means it will be 7.5 K vector. Now, the displacement vector for both the applied force at point A and point B are known. Already the force vector has been calculated. This is force at B and this is force at A. That is what has been written here. We know that M vector will be equal to R vector cross F vector. So here R vector is 15 K vector, which is at A, into, this is what, minus 40 cos theta I vector minus 40 sin theta j vector. That will give the moment of this force about the point C. Now let us move with the second force, the 40 Newton force. Here the displacement vector is 7.5 K vector. So 7.5 K vector and the force vector is 40 I vector. So cross 40 I vector. Now solving this one, you will be getting the moment about the point C in terms of vector is 600 sin theta I vector, that is multiplying this one and simplifying, plus 300 into 1 minus 2 cos theta j vector. So if I am simplifying this one in the sense, you will be getting minus 600, 15 into 40, 600 cos theta, K cross I will give j vector. So this will become negative. Now moving on with the second component, 15K cross minus 40 sin j. So K cross j will give I vector, that will be positive. Right. So in that case, it will be plus 15 into 40 will comes 600 sin theta I vector. And this one is K cross I. So that will give j vector, that is plus 7.5 into 400. So which comes 300 j vector. So that is what here 600 sin theta I vector has been taken separately, whereas going on with the 300 j component, 300 has been taken common. So you will be getting 1 minus 2 into cos theta into j vector. Now they gave the condition for no rotation about the vertical with respect to point C. The y component of MC, that is the moment about the point C, must be 0. That is the j component of the moment about the point C should be equated to 0. That is 300 into 1 minus 2 cos theta, which will be equal to 0. Solving, you will be getting the angle theta, which is 60 degree. Now we can substitute the value of this 60 degree in both the equations, that is resultant force as well as the moment about the point C. We can get the value of the resultant as well as the moment. This is what the question has been asked. We are supposed to calculate the rotation or otherwise the resultant force coupled system about the point C in such a way that due to the application of this wrench forces, the pipe system should not rotate about the y-axis with respect to point C. Now, let us summarize today's lecture. A wrench is a special force coupled system in which the forces and couples are parallel wrenches produces combined translation and rotation, which are commonly encountered in fasteners, pipes, shafts, and mechanical joints. So understanding wrench behavior is crucial for safe engineering design. To conclude, wrench applications bridge the gap between theory and real world mechanics. They reinforce the importance of moments, couples, and the transfer of force. These concepts are fundamental for advanced studies in strength of materials, machine design, as well as structural engineering. Thank you.